So now in this video, we have a 555 timer wired in monostable mode. Monostable mode just means the output is high for a brief period of time, and in this case after you press the button there, and then it goes back to low. It's going to stay low until we press the button again. Normally, so it's not doing it now, but normally if you hold the button down, the output's going to stay high until you release the button. It'll exceed the timing that you set by the capacitor and resistor, and unless I can get the switch to bounce, which doesn't look like I'm going to be able to now, it's going to stay low even after you release the switch. If it bounces, there we go. So when I removed my finger, somehow I released it and accidentally made contact again, and it bounced back. So it's not terribly easy to do, actually, unless you happen to that was just me releasing it right at the right time. Doesn't always do that switch bounce, but if I release it just right, sometimes it does. So yeah, we're not going to dwell on that too much now. I just wanted to try to get it to falsely trigger when I release the switch before we moved over here. So it's about half of a microfarad right there. So much lower value than what we have here, and we got a 10K resistor on both sides. So about 20,000 ohms of resistance there that we need to discharge it. So, you know, much smaller value than you got there. So this should charge quicker than that one. So I don't think it's going to influence the timing at all if we hold down the switch. So what happens is you press the switch, it sees ground. Whether this capacitor is here or not, it'll get to ground to 2. But then the capacitor is going to charge, since we have the capacitor there now. And when it charges up to above a third of the supply voltage, pin 2 will basically see a high input at that point. It only responds to a low input. So even though we got the switch closed, that side will get positive enough to prevent pin 2 from doing anything. Pin 2 is more powerful than pin 6. So if the capacitor charges to 2/3 supply voltage, which is the timing, and pin 2 is still low, then pin 6 can't do anything, can't make it discharge. So the capacitor will just keep charging until it's fully charged. But as long as pin 2 has a high enough voltage above 1/3 supply, then pin 6 will discharge the capacitor and the output will go back low. Hopefully that makes sense. So yeah, we got that capacitor now. Press the button, and it does go low, sees ground, but then the capacitor starts charging. But you just need that, you know, real split second low there to set the output high, start charging the capacitor. And then that builds up more positive there, more negative there. Current will stop flowing at some point, and then pin 2 will see 5 volts again. And then when you release the switch, so the 555 did what it's going to do. It didn't notice pin 2 anymore. Pin 2 wasn't doing anything. Did its timing. And so it's like a second in this video. Then you release the switch. We have a resistor on both sides right there, so the capacitor can discharge there. If you think of conventional current, if you want to think of electrons, electrons flow that way. So that's one connection. That's a node, the positive supply. Both of these resistors are connected, you know, along wires and stuff to each other. So you can discharge the capacitor through there, even though it is one of the supply voltages. Doesn't matter. And you know, the proof is just that you saw the circuit working. So of course, red LED isn't as bright as the blue LED, so I got a lower value resistor, 220 ohm, 1K for the blue LED. Plus 555 timers connect to ground better. They connect to ground really good, whereas you lose about a volt, maybe a volt and a half. So it's like 4 volts now powering the red LED. So we have a lower value there. And again, this capacitor is just like half of a microfarad. So we will also, yeah, I wrote a note here. If you use like a capacitor like this, it doesn't have a smooth voltage transition. It kind of charges up to a curve, but usually that's not a problem. Just something to be aware of. And we just charge this up quick enough where we're out of the voltage range where it's going to hold the output high, even though the timing's done. So yeah, there you can see the resistor to pin 2. going to that jumper, this is the discharge resistor. I falsely triggered it with the screwdriver. That's basically the discharge resistor. This is the pull-up resistor for pin 2, but it's also a discharge. As I said before, they're both to the positive supply, so that means there's metal connecting the two. So we can do a path through that capacitor that doesn't affect the rest of the circuit. There's a switch to ground up there. So usually I work my way more positive up high, down towards more negative, but not always. So you can see that there. Also with the 555 timer, I like to work more positive to the left, more negative to the right. But there you can see the negative supply is pin 1 and the positive supply is pin 8. So you can come up with conventions that you like, but something will always pop up where you have to modify it. So always be aware of that. Things, even if they usually work out the way you like, not always. So that's the positive supply. And then of course the output's there. Right now, there you can see that's positive. So you know if the blue LED is lit up that the output is more negative to ground there. And then of course when the red LED lights up, its resistor is to the negative supply. So you know it has to be more positive for the red LED to light up. Basic 555 timer stuff. And be in monostable mode. Again, we have the capacitor needs to charge while the output is high, and then when it goes low, it discharges instantly to ground right there. Any current that trickles through the 10K resistor also goes to ground. So, you know, this is a simple modification. We just added a capacitor there and a resistor to let it discharge, and so figured I might as well use some time to just review the monostable mode 555 timer circuit for those that don't really know it terribly well. So that's it for this video. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.